Okay, so we were on number 6 on page 654, and we had just found the mass defect, but we're looking for the mass of the nucleus of an helium. So they gave us the binding energy, we found the mass defect, so we can now go to the equation mass defect is equal to the mass of the nucleus minus brackets the sum of the masses of all the neutrons plus the sum of the masses of all the protons. Oops, and I should write up here, of course, this is lost. And that becomes important because it's going to have to go in as a negative. So we're solving for this mass of the nucleus, so we'll bring this term over. So mass of the nucleus will equal delta M plus the sum of the masses of the neutrons plus the sum of the masses of the protons. So the mass of the nucleus will equal, so what we just found, but it has to go in as a negative because it's lost, 0.030381758 U's plus, there are 2 protons and 2 neutrons, so I lost my masses. They were on the back sheet. I should know them off by heart by now, but 1.00, it's always better to be safe, 8665 U's plus 2 times 1.007825 U's. The proton one I do know, it's the neutron one I always want to double check. And so we have negative 0.030381755 U plus 4.03298. And so you get a mass defect of 4.002598242 U's. Okay, so this is, I said mass defect, but this is really the mass of the helium nucleus. Okay, so then I also asked you to do the questions on this multiple choice sheet. All right, and so maybe we can just quickly go through them. I'm hoping they weren't bad. Even though the first ones were a little bit hard to figure out. Positively charged particles in the nucleus of an atom, I'm hoping you picked, are called protons. The nucleus of an isotope A of an element has a larger mass than the nucleus of isotope B of the same element. Compared to the number of protons in the nucleus of isotope A, the number in B should be smaller because it says A has a greater mass, so B, it must be smaller. Oh wait, protons. Compared to the number of protons, no, it should be the same. It's neutrons that would be smaller. Which is an isotope of Se40, too bad I can't see that, 4121. And so it also still has to be, I can't tell if it's Se or Sc, but it has to be this one, has to be the same element. All right, an atom consists of 9 protons, 9 electrons, and 10 neutrons. The number of nucleons should be 19. The total number of neutrons in the nucleus of an atom is equal to the mass number of the atom? No. The atomic number? No. The atomic number minus the mass number? No. The mass number minus the atomic number? Yes. What type of particle has a charge of 1.6 times 10 to the negative 19 and a rest mass of 1.67 times 10 to the negative 27? That has to be a proton, right? Because a neutron wouldn't have a charge, an electron has less mass, and an alpha particle has a lot more mass and a different charge. Which device makes visual observation of the path of a charged particle possible? It would be the cloud chamber. Right, because in the cloud you'll see the little zip of light. The Geiger counter, you'll just hear like a click, 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 telling you there's things there. Same with the Van der Graaf generator, and these are particle accelerators, and you want a detector. Which device could be used to give a positively charged particle sufficient kinetic energy to penetrate the nucleus of an atom? It has to be a particle accelerator, so it's going to be the Van der Graaf generator, because an electroscope is not a particle accelerator and the other two are detectors. What is the maximum amount of kinetic energy that may be gained by a proton accelerated through a potential difference of 50 volts? It should be, this is V equals W over Q, so W equals QV. So 1 elementary charge times 50 volts should be 50 electron volts. Choice 3. Which of the following is used to accelerate a charged particle? Not a photographic plate, not an electroscope, a cloud chamber is the detector. It has to be the cyclotron, that's the accelerator. Which describes the nuclear force that holds nucleons together? It should be strong, so eliminate the first two, and short range, so choice 4. What is the force which holds the nucleons of an atom together? Not a Coulomb force, not a magnetic force, not an atomic force, it is a nuclear force. The energy that must be supplied to a nucleus in order to separate it into its individual protons and neutrons is called the binding energy, right? It's the energy you have to put in to split the nucleus because it's the energy that's holding it together, and you have to match it to split it. When compared to the total mass of the nucleus, the mass of the nucleon, the mass of the nucleus is always less. Base your answers to 25 on the following. So it's giving us what mass they want us to use for the proton and the neutron. Notice it's a little bit different than your textbook. What is the mass defect? So for number 15, when I did it, I got choice 3. Okay, so it's helium, so 2 protons plus 2 neutrons, and then subtract that from the helium nucleus, and you should get this 0.030375. How much energy would be produced by 1 times 10 to the negative 3 kilograms of matter if it was entirely converted into energy? So you're going to do E equals mc squared here. So 1 to the negative 3 times 2.9979 times 10 to the 8th squared. So that's like 3 squared is 9, 8, 16, 15. So it should be choice 1, I believe. Just looking to see if, yeah, that's what I got to when I did it, with not in my head. Number 17, which isotope is used to define an atomic mass unit? That's carbon-12, choice 4. A pair of isotopes. So which one of these is a pair of isotopes? They have to be the same atom. So it has to be the one with the 2 uraniums, because the others are different atoms, and you can't have different elements in the same isotope. So it has to be the same number of protons, different number of neutrons. Of the following particles, the one that cannot be accelerated in an atom smashing machine is the neutron. Because in atom smashing machines, to accelerate them, they need to have charge, and a neutron doesn't have charge. Okay, they use electric fields and magnetic fields, and if you don't have a charge, it won't speed up. Number 20, which group of particles can all be detected by a cyclotron? Again, they would have to have, I can't see through here. I was going to say they have to have charge, but I need to double check that one. Choice 3. Proton, alpha particle, and electron. Yeah, so they do need to all have charge. I just needed to make sure. It's the charged particle that can be accelerated. Yeah, I was thinking it was a detector. Positron can be best described as a positively charged electron. The mass of a neutrino is less than an electron. It's a tiny little mass. 23 particles with mass between that and an electron and a positron. Oops, we didn't get to this one yet. We will, though, but you can't do that one, so I don't want to ruin the end of the story. Number 24, you can't do this one either. Number 25, which of the following are classified? Oh, okay, so 23, 24, 25, I need to remember to come back to when we do subatomic particles, okay? You can keep going with these whenever you're bored, because you are going to get to do the rest of them, so if you're bored, feel free to keep going. There'll be a few you can't do till we get to the end, but a lot of them you can still do. I just didn't want to assign too many at one time.